homework exercises are 13 through 34 all. I'll remind y'all all that we talked about yesterday that we have log, base, answer equal exponent. A logarithm is equal to an exponent. When we talk about exponential form, we have base raised to an exponent is equal to an answer. That's something you need to keep in mind for what we're doing today. Today, like I said, a logarithm is equal to an exponent. So all the rules for exponents are important. So I've written the rules for exponents up here again. Remember, x to the m times x to the n, you're going to add your exponents. X to the m over x to the n, you're going to subtract your exponents. X to the m raised to the n, you're going to multiply your exponents. Anything raised to the 0 power is equal to 1. Anything raised to a negative power is 1 over the number to the power. It's the same as the reciprocal. So we have a whole long list of properties that apply to logarithms that really come from the rules for exponents, as well as the fact that logarithm function and the exponential function are inverses. So the first little rule doesn't really have a name, but I've titled them inverses because they come from the fact that the properties are inverses, or the functions are inverses. Remember, for all positive numbers m, n, and b, where b is not equal to 1, then when these are equal, those are equal. When these are equal, those are equal. So an example might be log base 7 of 7 raised to the third, then x would be equal to 3. On the next one, you have an exponential function. So you have a base. So maybe you have 2 raised to a logarithm of the same base. So this base would have to be 2 as well. So then if you have 4 here, then x is equal to 4. Because these are the same, then 4 is equal to x, or the whole thing is equal to 4. The next property are called equality. These are extremely important. We use these a lot when we get to the word problems. And basically what it says is if log base b of x is equal to log base b of y, then x is equal to y. As long as these are equal, then these are equal. So my example says log base 3 of 2x is equal to log base 3 of 18. Then what do you know? Because these are equal, you know that 2x is equal to 18. So you could solve this and get x is equal to 9. The converse of this is also true. The converse, like I said, is also true. The converse is the method or the way we use it most often. It says if x is equal to y, then we know that log base b of x is equal to log base b of y. Like I said, this is very important. I would put stars by these. This says 2x is equal to 18, so we've got log base 3 of 2x is equal to log base 3 of 18, so 2x is equal to 18, so x is equal to 9. Okay, so yes. Down here, for instance, Cutter, if you had 6x is equal to 18, then we could say log base 2 of 6x is equal to log base 2 of 18. The next three properties are important. The first property is called the product property. And this part here, it's called expanded form. So that's called expanded form. So I have log base b of mn is equal to log base b of m plus log base b of n. Like I said, this is called expanded form. Alright, so I have two examples up here. The first example says log base 3 of 18. And if we were asked to write this in expanded form, we would say log base 3 of perhaps 6 plus log base 3 of 3. Okay? Yes. Or we could say log base 3 of 2 plus log base 3 of 9. As long as when you multiply them together, you get 18. On the next problem, I have log base 4 of 3. Log base 4 of 3y. That would be log base 4 of 3 plus log base 4 of y. It's not a base. Alright, so like I said before, this is called expanded form. You won't see that terminology in this textbook, but that's what it is. Okay, everybody okay with the product property? Okay, good. Next, we're going to look at the closure property. The closure property says log base b of m divided by m is equal to log base b of m minus log base b of n. These properties all come from the rules for exponents, and when you think about this rule, what are you doing? You're subtracting, right? Alright, so up here I have log base 3 of x divided by 5. To write this in expanded form, you would say log base 3 of x minus log base 3 of 5. Next, we have the power property. The power property says log base b of m raised to the r is equal to r times log base b of m. Once again, this is the expanded form. And what happened is r moved to the front of the logarithm. So we have an example here of log base 4 of 7 raised to the 5th power. If we were to write it in an expanded form, we would move 5 to the front of the logarithm and get 5 times log base 4 of 7. I have another example up here for the power property. I have log base 3 of the square root of m to the 5th power. So we need to look at what this really is. This is log base 3 of m to the 5/2 power. So we could actually move that exponent to the front of the logarithm to get 5/2 times log base 3 of m. I have some other properties for logarithms, which is sort of similar to what is called the inverse property. Log base b of b. Remember I said when b is the same, the whole thing is equal to this. So that's why I have log base b of b. It is equal to 1. And when you think about it, if you rewrote this in exponential form, the base is b, the exponent is 1, and all of that is equal to b. So you know that this one and this one are the same. Next property says log base b of 1 is equal to 0. I think there was a homework exercise with this on it. If you know anything raised to the 0th power is equal to 1. Remember, a logarithm is equal to an exponent. So if this exponent is 0, that something is this way. Susan? Let's go back, Susan, to the square root of x is equal to x to the 1/2 power. Okay? This is really log base 3 of m to the 5th raised to the nth power, right? So I multiplied those two together to get log base 3 of m to the 5/4. The power property says 0. And I want you to write the property beside every step tonight. And I will ask that type of thing on a test, so just get in the habit of doing this. If you write down each step and then the property beside it, the entire property, you'll learn the properties pretty quickly. Hold on. You'll notice here it says log base 9 of 18 minus log base 9 of 2x. You want to rewrite this as log base 9 of 18 divided by 2x is equal to log base 9 of 36. So you want to use your quotient property and go from the expanded form, which is what this form is, to a single logarithm. So write this property beside that step. And the next thing you want to notice is that these are the same. Because those are the same, you can use the equality property and say 18 over 2x is equal to 36. Now you just have a simple equation to solve. Yes. So the equality property is what you use to go there. Next, you want to solve your simple equation. So we have 18 is equal to 36 times 2x. So we have 18 is equal to 72x. So x is equal to 18 divided by 72. X is 24. On the next problem, I have 3 times log base 2 of 5 is equal to log base 2 of x. Once again, you need to rewrite this as a single logarithm. So I'm moving the exponent back to x. I have log base 2 of 5 is equal to log base 2 of x. The property I use to do that is the power property, but let's just write it out. Log base b of m raised to the r is equal to log base b r times log base b of m. Next, we have these are the same. They are single logarithms, so you can make 5 equal to x. The equality property, if log base b of x is equal to log base b of y, then x is equal to y. Yes. So obviously get x is 125. All right. I'll give you a minute to example 5 down. So once again, the first thing you want to do is write the left-hand side as a single logarithm. So plus means to multiply. So we have log base 2 of 3x times 5, which y'all could have written as 15, is equal to log base 2 of 30. So log base b of mn is equal to log base b of m plus log base b of n. Finish. All right, so 3x times 5 is how much, y'all? So that's 15x is equal to log base 2. Because these are equal, they are a single logarithm, I can use the equality property. The equality property says if log base b of x is equal to log base b of y, then x is equal to y. So 15x is equal to 30, so x is equal to 2. I'm writing it out so you know what the false box is. This problem is extremely important. Some of your homework exercises are like this. What is the difference between this problem and the ones we've done so far? Say that again, Jordan. The answer is not a logarithm. So you're not equal to a logarithm. Go back and look at these other problems. You see where they are all equal to a logarithm. But on this example, it's not equal to a logarithm. So put stars by it because it's solved differently. It is not equal to a logarithm. The first thing we want to do is to rewrite the left-hand side as a single logarithm. So plus means to multiply. So we have log base 10 of a times a plus 21 is equal to 2. So we wrote the expanded form as a single logarithm on the left-hand side of the equation. We could multiply this. We have log base 10 of a squared plus 21a is equal to 2. But because we don't have a logarithm over here, we have to work the problem differently. So we have to change it to exponential form. So, get Alright, so what's the base, guys? 10. What's the exponent? And all of it's equal to a squared plus 21a. What kind of equation do you have? Quadratic. Good. So we have a squared plus 21a minus 100 is equal to 0. You can use the quadratic formula, or in this case, you should be able to factor it pretty easily. So it factors to a plus 25 times a minus 4 equals 0. We get a is equal to negative 25, and a is equal to 4. So what's the answer? 4. Answer 4. Why? Because the domain of a logarithm is negative, never a negative number. So you plug in negative 25, you get a negative number here. So if it turned out, when you plug it in, if it turned out to be positive, in other words, if you plugged it in here, that turned out to be positive. If it turned out to be positive when you plugged it in, you could use it. Negative 25 gives you negative 4, right? All right, here's some more examples. Let's look at these. All right. My first example up here says log base 3 of 15 and asks you just to write it in an expanded form. Obviously, there's only 2 factors of 15, so you have log base 3 of 3 plus log base 3 of 5. The next example, number 2, is a little bit more difficult. So let's do this first. Rewrite this log base again of 2 divided by n raised to 1. When you do that, you get log base of 3 power divided by n to the 1th power. Everybody okay with that? So divided by means you're going to subtract, right? So you have log base n of m is 3x minus log base n of n is 1. All right, so we're not done though. We're not totally expanded. So we need to move to exponents. So we get 3x times log base n plus log base. Now we're totally expanded. Right? I think I'll skip the time. All right. So on to info. Info. Remember that the domain is all positive real numbers. keep the variable on the same side of the inequality. All right, so what's the base, guys? Base 5, the exponent 6, which is x on the same side of the solve. So we have x greater than 25. We really know this stuff. And the restriction is greater than 0. We don't need the restriction, right? But x is greater than 25. It's always greater than x. Whatever this is, it's always greater than 0. So this is the negative restriction. We have 2x minus 1 is greater than 0, so 2x is greater than 1, so x is greater than 1. All right, so what's the base? What's the exponent? So we have 2x minus 1 less than 2x less than 9. So 2x is less than x less than 5. That means we can choose a negative number, but we can't have a negative number, so we're going to have restriction. What? 1/2, right? So x such that 1/2 is less than x is less than 5. We probably should have put this. All right, ready? All right. Well, let's talk about why these properties come about. The inverse property. The inverse property, the reason I call them the inverse properties is because when you take two functions that are inverses and find the composite, they're equal to the identity. So if we have the function f of x b raised to x power, we have the function b of x is equal to log base b of x, and you combine these two, what happens? Well, you're going to take all of this and plug it in for x, right? Okay. So you would have y b raised to log base b of x. Okay. So because we know there are inverses, we know they're equal to the identity or equal to x. Okay? So that's why we have 5 raised to log base 5 of 2, then these are equal, the whole thing of this is 2. take it b of x. And so you have log base b of b raised to x. Once again, you know that these are inverses, so the whole thing is equal to x. So an example might be log base 7 of 7 raised to the third. So x is equal to 3. This is saying that the whole thing's equal to that. That's an exponent. This is a number. Yes. The base is always written on the tail of the G. That's why I make my G tail so long. All right. Yes. All right. So this problem number 59. All right, says log base 6 of 2x minus 3 is equal to log base 6 of the x plus 2. The equality property says because these are equal, just make these equal. 2x minus 3 is equal to x plus 2. So it's a fairly simple problem to solve. If you subtract x on both sides and add 3, you get x is equal to 5. That's easy. Any questions about how to use the equality property? That's one way to use it. That's not the way we're going to use it. But that's probably what's on the homework tonight. We already done these. Not this one. All right. So the equality property says is equal. So we have 3x minus 1 is equal to 2x squared. So we have 2x squared minus 3x plus 1 is equal to 0. It is a quadratic equation. You can factor it. So if you're looking for the factors of 2, multiply together gives you 2, and add together gives you negative 1. I mean negative 3, so negative 2 and negative 1. So we have 2 over negative 2 and 2 over negative 1. So we have x minus 1 and 2x minus 1 is equal to 0. So x is equal to 1 and x is equal to 1/8. Both of those are solutions. You might want to check your answer and plug them back in. The next example says log base 4 of 5 plus log base 4 of x is equal to log base 4 of 20. Once again, you want to write the left-hand side as a single logarithm. So plus means to multiply. So we have log base 4 of 5x is equal to log base 4 of 20. So we multiply these together here. Once we've done that, we can use the equality property and drop the logarithms off of there and get 5x is equal to 20, so x is equal to 4. You cannot use the equality property unless there is a logarithm on both sides of the equation and it is a single logarithm.